You should make several things during the next competition year. I think you'll enjoy it a lot. So, you've probably heard of a design and build exercise, right? I'd like to encourage you not to think about it as a design and build exercise, because if you design it and then build it, it will suck and you'll be sad. Don't do it. Think about a bit of prototyping instead, right? You want to test your ideas on a small scale, quickly, bit of agility, design it, prototype it, then build it. It'll still suck. I'd like to encourage you to think about it as a more kind of iterative process, where you go round and round, you design a little element of your robot, maybe prototype it with some sticky back plastic and some stuff that you've got lying around, build that element of it onto your robot, see if it works, and then do it bit by bit, going round and round this loop. And I'd encourage you to go around this loop sort of 2, 3, 4 times in the time that you've got to build your robots. That's the only way you can really answer these kinds of complex design questions, and it's a good way of avoiding that thing where you're stuck in a big group discussion and someone thinks that their idea is better and someone else thinks that their idea is better, and you go back and forth and back and forth. Really, you just got to test it at the end of the day. Try both on a small scale, or full scale if you can, and it'll stop you getting stuck in these endless debates. It's also just impossible to think of everything that might go wrong with your design, so you just got to try it out. So prototyping stuff is easy. You can do it with bits of cardboard and scissors and pens and paper and whatever you've got lying around your classrooms. You don't need to necessarily go into the sort of DT labs or whatever. You can build stuff out of Lego, which I'm a big fan of Lego. I think it's maybe the man I am today. Also, you'd be amazed how quickly you can get stuff done in the workshop. If you're prepared to maybe sacrifice a little bit of precision, you can just really quickly cut up bits of wood by hand, screw them together really quickly, and try out some, several different iterations, take bits off, cut them into a new shape, put them back on again. So don't worry too much about polishing it and getting it perfect. You can do that later on, after the competition. So really, really super important. Those 3 objectives that your robot's got, I put them up on the first slide. I forgot to mention them. Basically, you've got to probably drive around, maybe pick up cubes or at least shove them around. That would be the bare minimum. Then hopefully we really want you to pick up the cubes and put them on the plinths, because that's where the really sort of crazy creativity is going to come in your mechanical design. So just kind of have a think about some of those issues. So the first thing you're going to need to do is move around with some kind of determinism, some kind of agency. And you probably know how a car steers, right? You've got these 2 wheels at the front, and you can point them in different directions, and your robot will follow. And that's a very, very energy efficient way of steering, particularly for larger vehicles. But it might be a little bit tricky. So does anyone know how a tank steers? Yes.
One wheel forward and the other wheel backward, and just spin on the spot.
Exactly, yeah. One wheel forward, one wheel backwards, you spin. Or you can go in a straight line with one wheel going a little bit faster than the other one, and you'll turn in a sort of gentle curve. So this might be a good way of steering. There's a more crazy, radical option as well. These things are called omni-wheels, and it's a bit more complicated. Your robot would need 4 motors that can go at different speeds. But then your robot can you can crab sideways, walk forwards, backwards, it can go in smooth curves, and spin on the spot, all kinds of crazy stuff. No one's ever done this yet in SR, so that would be pretty crazy if you do that. To make your wheels go round, you of course need some motors, and we leave it to you to find these motors in the wild. The big question is, how big should your motor be? How much torque does it need to produce to move your robot along? Does anyone know? No, you can't know. You have to prototype. And with these little electric motors that you buy, they'll drive very, very, very quickly with very little force. They might go at sort of thousands of revolutions per minute. So you need some way of turning that high speed, low torque electric motor property into a kind of relatively low speed, high torque arrangement for moving your robot along. And the way to do that is with gears. You can use belts, you can use chains and different sizes of sprockets, the way your bicycle works. Or you can buy these motors which have a gearbox mounted on the end already. They're very, very convenient, so I might encourage you to have a look at those. And you can get also kits of reconfigurable gearboxes. So if you're not really sure where you want to be on this kind of torque to speed trade-off that you have to make, then you might be able to get a gearbox with several different sizes of gears that you can substitute in and out to experiment really quickly to find out how much torque and speed you can get. Wheels, obviously you need enough grip, but don't have an infinite amount of grip, because if you've got a tank steering robot, it relies on the fact that it has to kind of skid a little bit over the ground. So again, there's a little trade-off to make there. If it's got perfect grip, it might just not turn. Hasn't been a big deal so far, but it was a big deal for a robot that I made once upon a time with some good friends, and it could only go in straight lines. No matter how much we added to the speed on one side and subtract from the other, only went in straight lines. For that reason. This is a problem that everyone comes to at some point. They've got a motor and a wheel, or obviously a gearbox in between, and oh no, they don't fit. Different sizes of things. If you've got a really good workshop, you might have some lathes available. You can make some custom adapters to fit these two things into each other. The good news is you can also buy these as a kind of off-the-shelf component ready to go. They're called shaft couplers or shaft adapters. I bet you're going to need one of those at some point. Put that in the middle, and it'll take up the slack between the two things. Yes, this is a good thing to get this right, because it's probably easy to make something that sort of looks like it might hold up, but it's a common thing for teams to end up with a motor going around and the wheels stationary, and it's just a really sad thing for your robot to fail on, isn't it, really? So try and get that bit nicely built, and I think you're then in a pretty good position. Also here you can see I've just got my motor connected straight to my wheel, which might not be the best thing ever, because all of the mechanical load, all the weight of your robot is straight on that little shaft. And some motors can handle that, so maybe have a look at the specifications of your gearbox. Also bear in mind that it's not just a kind of static situation. If your robot's getting bashed around and things, there might be several times its weight on the axle at some moments. So maybe think about putting some sort of bearings in between or sort of holding the axle onto the chassis of your robot, and then the motor only needs to supply the rotational torque, which is what it's designed for, and the mechanical gravitational load on your machine is being handled by these bearings. And these are again standard parts. You can get them from RS or Technobots or various different places. I'll talk about that a little bit at the end. There's obviously alternatives to driving around with wheels. We could have tracks. No one's done that yet either. Possibly because it doesn't really make sense.
Last year.
It's been done.
We did it last year. I missed it. Well, yeah, do it better, bigger, faster.
So tried on there.
Legs as well. We haven't seen legs yet, I'm pretty sure. So
Oh, I did better.
Also, once you've got all these bits, you need to attach them to some sort of thing. That's called a chassis, the kind of body of your robot. It could be as simple as a sheet of wood that you cut into the right shape. It's obviously supplying some sort of mechanical support. Just think a little bit about where the centre of mass is of this thing. If you've got your battery sort of right at one end, then the wheels under that battery are going to have really good grip, but the ones at the front might not. We might overbalance. So just think about that, particularly if you're lifting things up. You've got to lift these topings up, you might just fall over. So don't end up in that situation. Picking up the cubes is where the real mechanical creativity, I think, is going to come in. And you can get some really good inspiration by looking at other things that pick up objects in the world. Also, these cubes are quite tall compared to the height of your robot. So it might need a kind of telescoping mechanism that can go up above its head. So maybe have a look at forklifts. The way they do that, they can lift things up to many times their own height with quite a simple telescoping slide mechanism and a little chain hoist or something. And you could potentially build something like that. It'd be very cool. Also, this photo on the right here, not that obvious, but this is this chap from the BBC, Jed Stansfield, climbing up a building with vacuum cleaner powered gripping plates. So perhaps this would be an interesting way of picking up your cubes. They've got quite flat surfaces, they're very light, so maybe you can grip them with some kind of vacuum gripper and you don't need some complex mechanical arms. I don't know, you might need to think about how much power is available though, because he's got several kilowatts of vacuum cleaner attached to his back. Although he just seems to be doing it wirelessly, as far as I can tell. I'm not quite sure what's going on there, but vacuum cleaners use a lot of power, so you know, might be interesting. Just think about how much battery life you're going to get, and prototype to find out. Finally, buying things. It is actually possible. These things are ubiquitous, and it's getting easier and easier to buy mechanical components. The hobby market is sort of really exploding at the moment. So places like Technobots and Cool Components, they stock these little mechanical bits and bobs like bearings and gearboxes and motors and all of that. eBay's really excellent as well if you know that, I don't know, there might be some consumer device that contains some nice mechanism, I don't know, like a Roomba or something. You might be able to take some bits off the Roomba vacuum cleaner to get a vacuum source or something like this. Have a look for some broken ones on eBay and take them apart. At least see how they did it. It might inspire you that way, or just reuse some of the stuff that they're using. Also, local hardware shops are excellent, much better than B&Q, because normally they contain wizened old guys at the back who you can talk to, and they're massively knowledgeable about things. And if you sort of come in with two things and say, I'm not quite sure how I can get these to attach to each other, you can rely on a small independent hardware shop being able to tell you the way. Also, yeah, B&Q is very convenient. That's about it. So yeah, just have a lot of fun and really unleash some mechanical creativity. We want to see people not just kind of shoving cubes, we want to see people bending down and picking them up and stacking them. So if you do that, we'll be very impressed. Thanks very much.